everyone. Welcome to the series of the USCS Coding Challenge application video walkthrough. In this channel, you are going to see how Anika Vital team prepares, designs, and implements a system with application and infrastructure components and pack the solution to meet the customer's requirement. In the previous sessions, we have covered the system design, development, and deployment. Today, we will take a look at the monitoring and optimization. I wish it does not only explain how our team completes the task, but also give you an idea on how to choose appropriate technology to meet your customer's requirement. For today's session, I divide the content into 4 parts. We'll start with how to monitor the front-end application endpoint. After that, we will seek for an performance improvement made from the application packing. We will end this session by taking a look at the infrastructure optimization to reduce the latency. Okay, let's get started with the application monitoring. Monitoring your web application's performance is essential for ensuring a smooth user experience, maintaining user satisfaction, and achieving business goals. Application monitoring is a process of tracking, collecting, and analyzing data about application performance, availability, and user interaction in real time. It helps us to ensure the high availability and reliability of applications. It enhances user satisfaction and retention. Besides, it also reduces downtime and operational costs and provides insight for continuous improvement. There are some common challenges we may see when monitoring and optimizing the application. One of them is the complexity of modern distributed systems, which make us to make different methods to monitor front-end and back-end. Besides, we need to balance the cost with performance goals, which is going to be discussed at the end of this presentation. For assessing and optimizing web application, ensuring they meet modern standards for performance, accessibility, and user experience, we bring Google Lighthouse into our CI/CD pipeline. Lighthouse can be executed in Chrome DevTools from the command line as a node module. Give Lighthouse a URL to audit. It runs a series of audits against the page, and then it generates a report on how well the page performed. Use the failed audits as indicators for how to improve the page. Each audit has a reference that explains why the audit is important, as well as how to fix it. As developers, we want to run Lighthouse in Chrome DevTools before submitting the code change to evaluate if it brings positive or negative impacts. Open Chrome DevTools and click the Lighthouse tab. Click Analyze Page Load. DevTools show you a list of audit categories. Leave them all enabled. Click Run Audit. After 30 to 60 seconds, Lighthouse gives you a report on the page. You can also automate your Lighthouse runs with shell scripts. Once the shell script is placed in a GitHub action pipeline, the audit will be triggered every time the target source branch is updated. You can pause this video and take a look at the sample code for running Lighthouse through GitHub Actions. The generated report consists of 4 sections. Time to interactive (TTI) is one of the 6 metrics tracked in the performance section of the Lighthouse report. Each metric captures some aspect of page load speed. The Lighthouse Accessibility Score is a weighted average of all accessibility audits. Each accessibility audit is a pass or fail. Unlike the performance audits, a page doesn't get points for partially parsing an accessibility audit. For example, if some buttons on a page have accessible names, but others do not, the page gets a 0 for the buttons do not have an accessible name audit. Best practice and SEO sections scan some common issues and provide suggestions to fix. Now we have a good understanding on how the audit of the applications. Let's take a look at how can we do to make it run faster. As an application is provided through a S3 bucket and running in user's browser, we cannot accelerate the accessing speed by adding more servers resource, but transfer the application artifacts to the client side within a shorter time. Reducing the latency between the client and the S3 bucket helps, and it is going to be discussed in the next section. You can also reduce the size of the application artifact to get the file transfer completed sooner. Minifying the artifact from a React web project is a standard process for optimizing the app's performance by reducing the file size of the JavaScript, CSS, and HTML files. You can use a built-in React scripts for production build. If your React project was created with Create React App, it includes built-in support for minification when creating a production build. Once built, JavaScript files are minified using Tensor. CSS files are minified using CSS Nano, and the build process optimized images and includes hashed file names for cache busting as well. You can also minify index.html or other HTML files. Use the HTML Webpack plugin with the minify option. Once minified, the artifact also gets split into small chunks and becomes easier for users' browser to download in parallel. In addition to the application improvement, we also take the advantage of the modern infrastructure services to optimize the system performance. The service we introduced is CDN, which stands for Content Delivery Network. It improves application performance by caching content on server distributed globally, thereby enhancing speed, reliability, and user experience. Here's how. Reduced latency. CDNs have edge servers located closer to user, reducing the time it takes for requests to travel between the client and the origin server. Advanced CDNs use algorithms to determine the fastest, least congested paths for data transmission. Improved load times. Static assets like HTML, CSS, JavaScript, images, and videos are stored on CDN edge servers. Users fetch those assets from the nearest server instead of the origin. CDNs often compress content and optimize media, such as resizing images, for faster delivery. Better availability and reliability. CDNs distribute traffic across multiple servers, preventing overloading any single server. In case one server fails, CDNs redirect requests to the next closest server, ensuring uninterrupted service. Scalability. During high-traffic events, CDNs handle the surge by balancing the load across multiple servers, preventing downtime or slowdowns. Enhanced security. CDNs absorb and filter large-scale attacks before they reach to the origin server. Many CDNs handle encryption and decryption, improving the origin server's efficiency. Global reach. For applications with an international user base, CDNs ensure the consistent performance across regions by delivering content from servers closest to each user's location. The CDN service provided by AWS is Amazon CloudFront, which can fast, securely, and globally deliver data, videos, applications, and APIs with low latency and high transfer speed. Here's a breakdown of how CloudFront works. Distribution setup. You specify origin servers, which are the backend source where CloudFront retrieves your content, which is the S3 bucket in your case. You also determine how different types of content are cached or handled. Edge locations. CloudFront has a global network of edge locations and regional edge caches, which content is cached closer to user. When user requests content, the request is routed to the nearest edge location. Request workflow. A user accesses your application via a URL linked to the CloudFront distribution domain. If the requested content is cached at the edge location, it is immediately delivered to the user, which is called cache hit. If not, CloudFront fetches the content from the origin server, which is called cache miss, and cache it at the edge location and serve it to the user. Subsequent users requesting the same content get it directly from the cache, improving speed. Performance optimization. CloudFront stores cached version of your content based on TTL, time to life settings. It can compress and optimize dynamic content on the fly, as well as serve personalized content. Cost efficiency. Costs are based on the data transfer and requests, which makes CloudFront scalable and cost-effective. It reduces origin fetches and cost by centralizing caching. Integration with AWS services. It works seamlessly with other AWS services like S3, EC2, Elastic Load Balancer, and Route 53 to build highly permanent and secure application. By offloading work from the origin server and enhancing delivery speed, CloudFront significantly boosts application performance, user satisfaction, and scalability. I hope you learned how do we monitor and improve the application performance today. Thanks for watching, and see you in the next video.